Thank you so much for joining. Continue inviting a friend. Continue inviting a friend. Yes. So as I promised, today we are going to cover paper 1, section 2, the long questions, the 10-mark questions. The 10-mark questions. That is what we're going to be discussing in the next few minutes. In the next few minutes. Continue joining, continue joining. Welcome all. Welcome, welcome, welcome. Click the share button. Click the share button. Make sure you invite a friend. Invite someone. Invite someone you know. Share the link in your status. Share it in several WhatsApp groups as we are going to start. Make sure a friend has joined. Make sure a friend has joined. Yes. Continue joining. Continue joining. I can see we are around 10. Yes, continue joining. Continue joining. Make sure you have enough data. Okay, we can get started. We can get started. We got a question here, number 18. Remember, we are doing a section 2. The number 17 has already been covered in a certain lesson. Let us begin with number 18 in this case. The marks scored by 30 students in a test were recorded as follows. The marks scored by 30 students in a test were recorded as follows. So let us look at the marks scored by some 30 students. Some 30 students. The marks were recorded as follows from 30 students. So these are the marks. They are distributed in this page. Then we are told by the examiner, starting with the class 18 to 22, starting with 18 to 22, make a frequency distribution table for the data. Make a frequency distribution table for the data. That is exactly what we are going to prepare. A frequency distribution table. And I'll begin with the class which we've been instructed to start with. 18 to 22. So I can have the classes here. I can begin with class. I can begin with the class. Then there is what we call the tally. Then after tallying now, I go to what I call now the frequency itself. Now I sum up the tally to get the frequencies. To get the frequencies. Frequency can be abbreviated F, small letter F. I get the frequencies. We might develop the table later to other quantities, but for now, let me begin with the frequencies, the tally, and the classes. The first class we're going to begin with is the class 18 to 22. 18 to 22. Then after this, we can go to another class. Remember, we are going to have classes until we accommodate the largest figure in this data. And the largest is a 44. The largest is a 44. So from 18, the least, to 44, the greatest. To 44, the greatest. So which means because the difference here is a 4, we can start from 23 to 27, 23 to 27. Then from the other class is going to be from 28 to 32. The other class is going to be from 33 to 37, 33 to 37. Another class is going to be from 38 to 42, 38 to 42. I think the space was not enough here. The space is not sufficient, but I'm going to extend my page and have the last class lying in the space below this sentence. So I'm going to have 43 all the way to 47. So those are the classes. At least the least is accommodated in the first class, and the greatest value is also accommodated in the final class here. So we can now start distributing the marks into the respective classes. We can start distributing the marks into the respective classes. And I will handle all the marks at a go. So this is how you are going to be using your data when you are given data which is not in groups. This is how you're going to do it. You begin with the first one here, which is 41. Then you take it to the class where it lies. So 41 is in this class, so that's 1. The next is 43. This one should be in the next class here. The next one is a 34, and 34 should be in this class. The next is a 28, so 28 is in this class. 19 is in the first one. 22 also in the first one. 32 is in this one here. 38 is in the class here. 22 is in the first class. 18 is also in the first class. Then 25 is in this class. 33 is found in this class. We have 30. 30 is going to be found in this class. 41 is in this class. 36 will be in this class. 31 is in this class. 28 also in this class. So these are already 4. So the fifth one should just cut across like that. That 7 is in this class. 35, the same class. So because they are already 4, now the fifth one should cross like that. This is how we prepare a frequency distribution table. So after that is 35, we can go to 34. 34 also in the same class. 19 is in this class. We have already 4, so we have the fifth one like that. 22, the same class. 29 is in this class. Is a 29. 23 is found in this class. We have a 29. 29 is going to lie in this class. We have 44 in the final class here. We have 26 in this class. 27 will be in the same class. 29 will be in this class. 36 finally. 36 is going to lie in this class. 36. Therefore, that is how the scores are distributed. That is how the scores are distributed. You just cut each cross, each of the scores, you cut the cross and you indicate in the class immediately. Then after that, now we can check the totals now. This is going to be 5 plus 1, which is 6. So the frequency here is 6. This is going to be 4. This is going to be 5 plus 3. This is 8. This is going to be 5 plus 2, giving us a 7. This is going to be 3. And this is going to be 2. That is going to be 2. So we can confirm whether we have attended to our 30 students by computing what we call the cumulative frequencies. So we can check cumulative frequency for this data. In this case, we're going to start with 6, then plus 4. This gives us a 10, plus 8. This gives us 18, plus 7. This gives us 25. 25 plus 3 gives us 28. Then finally we have 2 giving us 30. Therefore the totals is 30. We have distributed the marks for the 30 students. Now with the frequency distribution table, we can attend to the few questions thereafter. Using the frequency distribution in A above, calculate. The first one is the mean. The second one is the median. So we can begin by calculating the mean. The mean is usually abbreviated as the mean of x, which is calculated by the summation of f of x divided by the summation of f. Whatever we call x is the midpoint of each classes. So we can obtain the respective midpoints for the given classes, the respective midpoints, which we are calling x, so that we may get f of x, the product of each midpoint and the frequency. So with 18 and 22, we just need to add 18 and 22. Then we divide by 2. This gives us 20 as the midpoint. So with 20, we multiply it with a frequency of 6. This gives us 120 as the f of x. The next is going to be 23 plus 27. Then we divide by 2. This gives us 25. So the next midpoint is 25. We multiply 25 with the frequency there, which is 4. And this gives us exactly 100. We go to the next midpoint for 32 and 28. Remember, when we add 32 and 28, we're going to get 60. So the midpoint will be 30. Then 30 multiplied by 8 will give us 240. 240. The next is going to be 33 and 37. When we add them, we're going to get a 70 divided by 2, 35. 35 is the midpoint. So 35, I'll multiply with the frequency there, which is a 7. This gives us 245. That gives us 245. The next is going to be 38 and 42. When we add them, we get 80. Divided by 2, we're getting a midpoint of 40. Then 40 now will be multiplied by 3, and we will get 120. 120. The next is going to be 43 and 47. When we add them, we'll get 90. Divide by 2, we'll get a midpoint of 45. So 45 will be multiplied by 2 to give us 90. Then now with the f of x, we can get the summation now of f of x. The summation of f of x, and I'll use my calculator to compute the totals. 120 plus 100 plus 240 plus 245 plus 120 plus 90. This gives me 915. 915. So now I need to take my 915 and I divide it. I need to get now 915. I divide it with the sum of f, which is 30. And this will give us what we are calling the mean. So divide by 30, I'm getting 30.5. 30.5. So this is going to be the mean for the 30 students. 30.5. The next is going to be the median. To calculate the median, we need the formula that gives us the median. Median is given by L plus n out of 2 minus cumulative frequency before divided by frequency. Then we multiply everything here by the class width. So what we are having here in this formula is the lower class boundary of the median class plus total frequency, which is n, divided by 2, then minus cumulative frequency just before the median class, divided by frequency of the median class, multiplied by the width of the median class. So the first thing to be done before we get into the formula is identifying the median class. The median class. So we need to get total frequency out of 2. Total frequency is 30 out of 2. This gives us 15. So the class which contains the 15th student is the median class. And we are going to check that class using the frequency distribution table here. We just need to go to the cumulative frequencies and we see the class which contains the 15th student. So the first one is not having 15 because this is 6. The next one, this is 10. The third one, which is having 18, is the one which contains the 15th student. So this becomes our median class. That is the class we'll operate with, the median class. So now we substitute into the formula because we have identified our median class now. We start with L, which is the lower boundary of the median class. And now that the lower limit is 28, the lower boundary will be 27.5. So we begin with 27.5 plus n out of 2. That means total frequency out of 2. That out of 2 gives us 15 minus cumulative frequency just before the median class. Cumulative frequency just before the median class, which is 10. Then this one should be divided by frequency of the median class. So frequency of this median class is 8. The frequency is 8. Then we multiply with a class width of 5. Remember, the class width is usually obtained by taking the upper boundary minus the lower boundary. So 27.5 and 32.5, the difference is 5. So that is how we get the class boundary of a given class. And for our median class, we have it as 5. So now we can compute. Yeah, then after that we can, after multiplying by 5, we can add our 27.5. So that we have 30.625. So this is going to be the median for this data. The median for this data. Let me underline it. Yes, that is how we get the median. That is how we get the median. The next we've been told to draw a frequency polygon to represent the data. Frequency polygon to represent the data. Frequency polygon to represent this data. So for us to draw a frequency polygon, it should be noted that we just need to plot frequencies against midpoints. Frequencies against midpoints. This is what gives us whatever we are calling. This is what gives us whatever we are calling the frequency polygons. The frequency polygons. So we're going to draw first of all. Remember, frequencies are supposed to be on the vertical axis. We're going to have frequency here. To have frequency there. Then instead of midpoints, I can actually have the classes on this lower side. Then just have the classes. So that apart from the frequency polygon, we can also have what we call the histogram. And remember, by drawing a histogram, you just need to connect the centers of the bars. The centers of the bars to come up with a frequency polygon. So we can have the classes here or the marks. We can have the marks here. So the first mark is having a lower boundary of 17.5. Can begin with 17.5. 17.5 all the way to 22.5. Then from 22.5 we can go to 27.5. Then we have 32.5. Then from there we can have 37.5. Then from there we can have 42.5, and finally we can have 47.5. So those are the limits for the given data. Those are the limits. So the frequencies now, we have the highest frequency as 8. So we can just use intervals of from 0 at this point. We can have when we use 1, we will not be able to accommodate all of them, but let me check. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, with 1 we can have all of them accommodated. So let me begin with the class starting at 18 to 22.5. 18 to 22.5 is having a frequency of 6. So this class is having a frequency of 6. So that's where the class reaches. The other one a frequency of 4. The other one, this is 6. So the other one a frequency of 4, which is going to be here. Then the next one is 8. 8, which is going to be here. The next a frequency of 7, which is going to be here. The next one a frequency of 3, and 3 is here. Then finally we got 2, and 2 is here. So that's how the frequencies are. So I can now draw the bars to show the histogram for this data. That is the bar for the first class. Then for the second one, that is how we're going to have it. The third one, the highest height, that is how it shall be. Yes, that's how the third one is. Then the next one, this is how it shall be. Then we have this one. And finally, we got this one, whose height is just 2. So these are the bars. These are the bars showing us what we call the histogram. After identifying the histogram, when we join the midpoints, from this midpoint to this midpoint, then to the next midpoint without skipping successively to the next bar, like that, we're going to have what we call a frequency polygon. So the first midpoint should be dropped to the origin. Then now we join all the other midpoints from the first one to the second midpoint, then from this one to the third, in that order, then from this one to the next, which is here, then from this one, this is the last one, then it should be dropped to the last upper boundary. So now whatever we are having here now is what we call a frequency polygon, and it has been drawn on a histogram. Therefore, when you join all the midpoints of the bars making a histogram, you obtain a frequency polygon. I believe we are together. We can look at number 19, which is a question on solids, question on common solids, whereby we're going to find what we call a surface area, we're going to find volumes and unknown heights. So we can just begin. The first thing we are told here is that the solid is made up of a hemispherical part and a frustum of a cone. The top and bottom radius of the frustum are 5 centimeters and 15 centimeters respectively. The vertical height of the frustum is 24 centimeters. So as seen, we have the bottom radius as 15 centimeters, the top radius for the frustum as 5 centimeters, then the vertical height as 24. The first thing, determine the vertical height of the cone from which the frustum was cut. It is good to master that. For us to obtain a frustum, then there must have been a cone which was cut at a plane which is horizontal to the base, such that a frustum, as we can see, was obtained. So if we prolong this frustum, we will get the cone from which this frustum was obtained. So this is an original cone now. There is an original cone from which the frustum was obtained. Let me cut through the center. Now this one should tell you that we have the 24 centimeters here, the vertical height, and from this one, the smaller height which was cut is unknown. So we can determine it first of all before we get the original height. Therefore, we're going to use similarities and enlargements, whereby we will say the ratio of the radii, 15 and 5, should give us the same ratio as the heights because they are both lengths. So they use what we call linear scale factor. So the linear scale factor due to this 15 and 5 should be the same as due to the first height, the original, which is 24 plus h, divided by the smaller height, which is 8. So we can cross multiply and have 15h being equal to 5 by 24 is 120 plus 5h. When we group like terms together, we'll get 10h equals to 120, giving us h as 12. This means now the height of the cone from which this frustum is being obtained, the capital H, is going to be 12 and 24, giving us 36 centimeters. The next, we have part A here. This has already been done. Then part 2 we are told to calculate the volume of the solid correct to two decimal places. Correct to two decimal places. So these are very special instructions which are supposed to be adhered to. Remember, when you are told to calculate to two decimal places, we strictly mean the final answer should be to two decimal places. So you should avoid rounding off prematurely. So let us start working. For us to get the volume, we will need the volume of the two shapes. Remember, we have a frustum and we are also having an hemisphere. An hemisphere is a half of a sphere. A frustum is a portion of a cone. Therefore, we should get the two areas. We should get the two volumes, that is. We'll start with the frustum. Then we add the hemisphere. For us to get volume of a frustum, since it is conical, we need a third multiplied by pi r squared times h. This is the original cone from which the frustum was obtained. Then the smaller cone, we subtract it, which was cut away now. A third pi, the small radius squared times the small height. This one will give us volume of the frustum. The now volume of the sphere is usually obtained by 2/3 pi r cubed. So that is how we get volume of an hemisphere. Remember, volume of a sphere is 4/3 pi r cubed. And now that this is an hemisphere, then we need 2/3 instead of 4/3 pi r cubed. Now we can substitute into this formula. We will need a third. I can use 22/7 times a radius of 15 squared times the height of 36. Then I subtract a third, 22/7 times a radius of 5 squared and a height of 12. Then now, after getting this difference, I will need to add 2/3, a pi of 22/7, and a radius of 15, and I cube it. A radius of 15, and I cube it. So what I'm going to get now from this difference, when you compute, you're going to get 81, 71, and 3/7. Then I add from the hemisphere 70, 71, and 3/7, such that when I add the two, I'll get 15,243 and 6/7. But now we've been told to two decimal places. Therefore, I have to make the 6/7 a decimal, and that will be 86. Therefore, we need 15,243.86. These are cubic centimeters. Cubic centimeters. So that is basically how we get the volume of the solid there. You have to deal with the two parts, the hemisphere, and you add what we are calling the frustum. The next is the surface area of the solid, again to two decimal places. For us to get surface area, now there is a new dimension which has to be calculated. Remember, we had the vertical heights. And we are not having the slanting height. Now that the vertical height and the radius are meeting at right angles, then we can get the sloping heights using Pythagoras theorem. In this case, we will say 15 squared plus 36 squared. Then we take square root. When we take 15 squared and we add 36 squared and we obtain the square root, this will give us exactly 39. And we do the same for the smaller cone. That means we will take 5 squared and 12 squared, then we obtain the square root. This exactly gives us 12. centimeters. Now with 12 and 39, this will give us 13 centimeters. Now with 13 and 19, we can obtain volume of the frustum. Volume of a frustum means we need to get the curved surface area of the cone, and we subtract the curved surface of the smaller cone that was cut off. So in my working here, I will say the curved surface, the areas are several here. We need the curved surface area of frustum. That means we need pi RL, and we subtract pi RL, the smaller cone. So this means when I substitute, I'm going to have pi R, which is 15, enter L of 39, minus pi R of 5, enter L of 13. And that gives us, when we compute and to work out, the curved surface of the first one will be 1634. And 2 out of 7 square centimeters. That is now the curved surface of the frustum. We also need to get the top of the frustum, which is circular. So the surfaces here are several now. We have the circular part. And that means we'll get the top circle, which will be pi r squared. So a pi of 22 out of 7, a radius of 15 squared, 5 squared. The top is 5. So 22 out of 7 times 5 squared. This gives us a 78 and 4 out of 7 square centimeters. And finally, we have the curved surface, which is made of an hemisphere. So the curved surface of an hemisphere, remember, the surface area of a sphere is given by 4 pi r squared. So this will be 2 pi r squared, since it is the half of a sphere. Let me compute 2 times 2 over 7 times a radius of 15 squared. This is going to give us 14, 14, and 2 out of 7. 14, 14, and 2 out of 7 square centimeters. Then there is now what we are calling the total surface area, whereby we will add the 3 surfaces. The curved of the frustum, which is 16, 3, 4, and 2 out of 7. The top circle, 78 and 2 and 4 out of 7. Then the hemisphere, 14, 14, and 2 out of 7. This gives us a total of 31, 27, and 1 out of 7. These are square centimeters. Then we can now obey the instructions by making it 2 decimal places. Therefore, 1 out of 7 is 1.4. So we're going to have 3127.14 square centimeters. So that is basically how we should work out the surface area and also the volume of the common solids. Let me go to the next question. The next is a graphical question, the cubic curves. Not cubic, but quadratic, sorry. The examiner says in part A, draw the graph of the function y equals to 2x squared minus 3x minus 5 for -2 less than or equal to x, which is less than or equal to 3. Or rather, the range of x should be within -2 and 3. This means the first thing to be done is coming up with a table. Coming up with a table Therefore, I'll need a table of x and y. A table of x and y. And I come up with the several values within the range. Within the range. So I'll begin with, this is x, this is y. I'll begin with -2, -1, 0, 1, 2, 3. Yes, those are the several values of x, and I will need to substitute them in the equation so that I may come up with the respective or the corresponding values of y. So when x is -2, we need to substitute the -2 in this function, then we will come up with the value of y. So I'll need to begin with 2. I open brackets in the calculator. -2, then I square it. Then -3, I open brackets. The value of x is -2. Then I subtract 5. That is how I should key into the calc. This is giving me exactly 9. So the first value is 9. When I substitute -1, I'll get 0. I continue substituting 0, I'll get -5. I substitute 1, I'll get -6. I substitute 2, I'll get -3. I substitute 3, I'll get +4. So those are the values. Those are the values of x. Those are the values of x and the corresponding values of y. With this now, I can draw my graph of y against x. Y against x. So this is my axis. Remember to advise people to continue joining the lesson. Advise friends to continue joining. We're going to do the lesson. We are continuing. There are 3 more questions to come. And we are going to answer them. We're going to deal with the questions. We're going to deal with them. This is a 0, so we can have -1, -2, -3. We can have 1, 2, 3, 4. This is a 5. Then we're going to have now on the other axis, because we need to accommodate up to 9, and on the lower side up to -6. That means we will need 15 squares, and that might be challenging, so I'll use intervals of 2 instead of 1. So I'm going to have 2, 4, 6, 8, 10 for the positive side. On the lower side, -2, -4, -6, -8. Those are enough. So we can now start plotting. We need -2, +9. -2, +9. Remember, +9 is just in between 8 and 10. So that is the first plotted point. The next is going to be -1, 0. So -1, 0 should be here. -1, 0, that is the coordinate. The next should be 0, -5, 0, -5. -5 is in between -4 and 6. Exactly there. +1 and -6. So +1 and -6. This is where the point is. The next one is 2 and -3. So 2 and -3. -3 is in between -2 and -4, exactly there. The next one is going to be 3 and 4. So I'm going to have 3 and +4, which is this coordinate exactly. This coordinate. Therefore now I need to draw this line. this curve. That is, remember, a curve should be continuous. Curve should be continuous. A curve should be continuous. Curve should be continuous. Therefore, from here, I'm supposed to join all the dots without lifting my pen. I'm just supposed to connect them continuously. So from this first coordinate, I'm supposed to connect continuously. This is the turning point. The gradient changes. Yes. So that is how the curve is supposed to be. That is the curve for the function. For the function y equals to 2x squared minus 3x minus 5. So that is how the function's curve is supposed to look like. After the curve, we can now proceed to respond to a few questions. We are taught to use the graph to solve the equation 2x squared minus 3x minus 5 equals to 0. So we are supposed to subtract every equation from the plotted equation so that we may get the line that will guide us into solving the given equation. So we need y equals to 2x squared minus 3x minus 5. Then now we subtract this. We have 0. 2x squared minus 3x minus 5. And when we subtract the corresponding values, we will be getting a 0 in each case. A 0 in each case. And the line we are getting is y equals to 0. This line is also called the x-axis. So now we need to check where the curve cuts the x-axis. Where the curve cuts the x-axis is the solution to the given equation here. It is the solution to the given equation here. Therefore, the first point is x equals to -1. X equals to -1. And the next one, the value of x, wherever the curve is cutting the x-axis, x is going to be 2.4. 2.4. Exactly 2.4. Exactly 2.4. Again, we've been told to use the graph to solve the simultaneous equations. Y equals to 2x. This is 2x minus 3x minus 5. Y equals to 2x squared minus 3x minus 5. And y equals to negative 2x minus 2. So to solve them simultaneously, we just need to plot them on the same axis. And the first function is already plotted. So we need to plot now this straight line with a negative gradient. That means to plot this one, we need a table of x and y. Just a small table. We can have 3 values. So we can have, when x is 0, what will be the value of y? So y equals to -2. Where we have x, we put 0 minus 2. So this will be -2. When x is 1, the value of y is going to be -2 times 1. It makes it -2 minus 2. So -2 gives us a -4. And finally, when x is +2, we're going to have -2 times 2, giving us a -4. So -4, -2 should give us a -6. So now we can plot the 3 coordinates. We can plot the 3 coordinates. I can see you are still joining. Kindly continue inviting friends. The questions are very many. Even if you join us as we continue, you'll find something. Just continue joining. So 0, -2, 0, -2, this is the coordinate. Then 1, -4, 1, -4. So we'll have 1, -4, 1, -4. Then we will have okay, thank you for your patience. I'm sorry for a disconnection. I'm sorry for a disconnection. So we're going now to, we're going to plot the line now. We have the coordinates for the line. Now the line continues. So this is the line, y equals to -2x minus 2. -2x minus 2. This means now the line and the curve have been plotted on the same axis. And with such a plot, now, we can come up with the coordinates of the points where the line and the curve are intersecting. The first one is at x equals to -1. X equals to -1. X equals to -1. This is when y, when y equals to 0, because the first coordinate is here. The first coordinate is here, -1, 0. The next coordinate where they are intersecting is here, and this coordinate is 1.2 and -5. 1.2, -5. Therefore, x equals to 1.2 when y equals to -5.0. -5.0. So those are the solutions for the two simultaneous equations. Remember, one is squared. One has x squared. One of the equations is quadratic, in other words. So when it is quadratic, it means the values of x will be several, leading to several values of y. So the several values of x are -1 and 1.2, and the several values of y, which means the corresponding values of y, will be 5, -5, and 0. So that is how we read the coordinates to get this solution. The last mark is asking us something. He's asking us to write down the quadratic equation which the line y equals to -2x minus 2 is solving. So we've been given a straight line which solves a certain quadratic equation, and we don't know it. So which is that quadratic equation which has been solved by this line? We should know that we usually take the quadratic function, we subtract it from the main function which has been plotted, so that we get this straight line. This means we should add back now our straight line to the main function, so that we may know the quadratic equation which has been solved. So in simpler words, I mean, when we get the function and we had the quadratic equation which is being solved, we take the function, we subtract the quadratic equation being solved, we usually get the straight line. This means now that we have the line and the function, for us to get the equation of the quadratic function which is being solved, then we need to have it on this side, and the line will be subtracted from the function. Therefore, when we take the function which is y equals to 2x squared minus 3x minus 5, we are supposed to subtract the line. We are supposed to subtract the line here, and the line is y equals to, we have a 0 here, This is negative 2x minus 2. We subtract so that we may get the quadratic equation which was being solved. So when we subtract here, we get a 0. This gives us 2x squared minus 3x minus negative 2x. This gives us it makes it positive 2x. So we will have a negative x minus 5 minus negative 2. This makes it positive 2. So minus 5 plus 2 makes it a negative 3. Therefore, the equation which was solved using this line is the equation 2x squared minus x minus 3 equals to 0. Now you will discover that it is this equation that when subtracted, we will get the line here. So you take this function, you subtract the equation here, you get this line. So that's why we are given the line now to find the equation which had been solved by the line. So that is how we go about it. The next question is on linear motion. Remember, we are continuing with paper 1. Continue inviting friends so that you may study together. You can see you are increasing. That is encouraging. Number 21. The diagram below shows the speed time graph for a bus traveling between two stations. The bus starts from rest and accelerates uniformly for 75 seconds. It then travels at a constant speed for 150 seconds and finally decelerates uniformly for 100 seconds. So now with this information, we can feed some values on this graph, the speed time graph. So we are told for the first 75 seconds, so from here, from rest, within the first 75 seconds, this car was accelerating, this bus was accelerating. So within the first 75, it was accelerating. It attained a certain maximum velocity, which we don't know. But now we are told it moves with that constant velocity for the next 150 seconds. So when we add 150 to 75, this is the time it will have taken moving at a constant speed. We had 150 here, we'll get 225. Then finally, it decelerates uniformly for 100 seconds. So within another 100 seconds, which means we will find ourselves at 325 seconds. This is time in seconds, 325 seconds. Now that is the motion of the car now, of the bus. That is from 0, within 45, it was accelerating. Then from 75, for 150 seconds, that means until 225 seconds, it was moving at a uniform speed. Then now it decelerates for 100 seconds, which means we will be at 325 seconds. That is how the figures should be inserted in such a graph. So now we go to questions. Given that the distance between the two stations is 55 meters. This is 55 meters. Calculate the maximum speed in kilometers per hour attained by the bus. 52.25. This is the distance. In the analysis of this graph, it should be understood that the area under the graph gives us the total distance covered. Now that we have the distance covered, it means we have the area of this shape, which is trapezoidal. The shape is trapezoidal. So we can get now the height, which in this case will represent the maximum speed attained by this bus. Therefore, we're going to say that 52.25, which is the area representing the total distance covered, equals to half the two parallel sides of the trapezoidal shape. The first one is 325 And the other one, which is just from here to here, this one, the side here is going to be 150 multiplied by the unknown vertical height here. And this vertical height, as I have said, will become our speed. So height equals to, okay, we can first of all multiply by 2 both sides to have 5225 by 2, giving us 10,540. 10,540 equals to, now we have 10,540, 10,450, sorry, equals to, when we had 325 and 150, we're getting 475 h, which means to get h, we will need 10,450 divided by 475, and this gives us exactly 22. These are meters per second. Therefore, the highest height, the highest speed here attained is 22 meters per second. 22 meters per second. Now, this one should be converted to kilometers per hour. Should be converted to kilometers per hour. To convert to kilometers per hour, remember the 22, these are meters per second. The meters should be converted to kilometers by dividing them by 1,000. So it means we multiply them with 1/1,000 to make them to make the meters kilometers. We divide them by 1,000, and now on the other side we have the seconds, which have to be multiplied by 3600 to make them hours. 3600. Therefore, I'm going to have 22 multiplied by 5 out of 18. Yes, this will be 6.11 kilometers per hour. 6.11 kilometers per hour. The next is going to be the acceleration of the bus. Remember, acceleration is usually given by final speed minus initial speed out of time. Therefore, acceleration will be calculated by the final speed is 22. It started from rest, which is 0, divided by time. So it accelerated within 75 seconds. Therefore, we'll have 22 out of 75. This will give us 22 out of 75. This will give us 0.2933 meters per second squared, because this is acceleration, meters per second squared. So that is how we get acceleration. The final velocity attained minus initial velocity attained minus the initial where the particle began the acceleration, divided by the total time taken to accelerate, which is 75. Therefore, that is how we work out the acceleration. Acceleration cannot be in kilometers per hour squared. We just express it in meters per second squared. That is why I have not gone to the converted speed. Part C, a van left Nairobi at 8:30 a.m. and traveled towards Mombasa at an average speed of 80 kilometers per hour. Then at 8:30 a.m., a car left Nairobi and traveled along the same road at an average speed of 120 kilometers per hour. There is a correction here. It should be noted that a van left Nairobi at exactly 8. A van left Nairobi at 8 a.m. Then at 8:30 we have a car now starting. Therefore, we're going to work out the question here, which says calculate the distance covered by the car to catch up with the van. We work out something we call relative speed, relative distance, and relative time. That is what we're going to be working out now in this case. Therefore, we should know by the time the car is starting its journey, the van has already left. And because the car is beginning the journey at 8:30, and the van had started at exactly 8, it means the van has already traveled for 30 minutes, which translates to half an hour. So distance covered by van just before the car began will be time times speed. Time half an hour at a speed of 80 kilometers per hour, giving us 40 kilometers. So the van is already 40 kilometers away. Now, it is this distance which we call relative distance. So the relative distance in this case is going to be 40 kilometers, relative distance. We need to calculate what we call relative speed. And relative speed, when vehicles are following one another or when they are going to the same direction, we take the difference between their respective speeds. So we need 120, the speed of the car, and 80, the speed of the van. This gives us 40 kilometers per hour. Relative speed, 40 kilometers per hour. Therefore, this is the speed at which the car is approaching the van at. Therefore, using the relative speed, we will take relative time to cover the relative distance, which means relative time can be obtained by relative distance out of relative speed. So we need 40 out of 40 to give us exactly 1 hour. Therefore, the car will catch up with the van after exactly 1 hour. Therefore, we are calculating the distance covered by the car to catch up. If they will catch up after an hour and the car has a speed, then we can know the distance the car will cover. Distance is given by speed times time, 120 for 1 hour. This car is going to cover 120 kilometers so that it may catch up with the van. Then the next question, just on the same, we've been told to find something else. And this is find the time of the day when the car caught up with the van. So the time they are catching up is after an hour, and they are starting to move together at 8:30 a.m. So we just add 1 hour, and we say that the two are catching up at 9:30 a.m. That is the time they will catch up and begin moving together. We can go to the next question, number 22. We are winding up with the session 2. We are winding up. On the Cartesian plane below, triangle PQR has vertices 2, 3, 1, 2, 4, 1, while triangle PQR double prime has vertices negative 2, 3, negative 1, 2. We have a negative 4, 1. Those are the vertices, and the triangles have been drawn. Let me indicate them well. This is a triangle. Yes, those are the triangles. So now we are being told in part A, describe fully the transformation which maps triangle PQR onto triangle PQR double prime. The transformation mapping up these triangles to one another. We can connect P to P prime just to begin with. P to P prime. Then we join that line which has connected them After joining, we bisect the line. We bisect the line and see how the bisector behaves. So I can draw a bisector here for that line, a perpendicular bisector for that case, not just any bisector. This is the bisector. Then I also join something else like R and R prime. R and R prime. I join the two, R and R prime. Then I bisect. I bisect the line connecting R and R prime. I draw again the bisector, and the bisector is confirming to be the bisector for P and P prime. When I do the same for Q, and Q prime, then I bisect the line joining Q and Q prime, it confirms again that we are getting just the same bisector, and that tells us that this is a reflection. So to fully describe a reflection, we need to know that, or to mention that it is a reflection, and we also mention the mirror line. This is line x equals to 0, or rather the y axis. So the transformation which can map this triangle to this one is just a reflection along the line y-axis, or rather x equals to 0. So this one has been reflected to this side, P to this side, and Q to this side. We can confirm by seeing that from the mirror line, R and R prime are at equal distances. From the mirror line, Q and Q prime are at equal distances. From the mirror line, P and P prime equal distances. So now the transformation is fully described by mentioning that it is a reflection and quoting the mirror line, which is the y-axis, So we continue with the other part, which tells us that on the same plane, draw triangle PQR prime, the image of triangle PQR, and a reflection in the line y equals to negative x. Line y equals to negative x means if the value of x is 1, that of y is negative 1. So this coordinate 2 goes with negative 2, 3, negative 3. So the line should pass there. The line y equals to negative x. That is where the line should pass. So I'm going to produce the mirror line first before I begin my reflection. So that is the mirror line. Line y equals to negative x. Y equals to negative x. Now we can reflect. For us to reflect successively, we just have to drop a perpendicular. Because the line is not horizontal, neither is it vertical, we are supposed to drop perpendiculars from R. If I begin with R to the line, from R to the line, so standing here, can make an arc, and stand here, I also make an arc. Therefore now I can produce this line from R. I draw a perpendicular like that. Then now through that perpendicular, I need to stand at the mirror line, and I pick this distance to R. Then I transfer it to the other side. So this is where R prime is going to be. I do the same for Q and for P. Therefore, for me to continue, I need to stand at P and I do the same. So at P, to the mirror line, I drop a perpendicular. Let me extend the mirror line. So at P and Q, I will do the same. So let me begin with Q. I just need to make an arc, extend it to this side. Then standing on where the arc is cutting the line, I make an arc and I make an arc like that. Then I join that intersection with Q. So standing there, I join it with Q. I can even use a dotted perpendicular like that. Then now standing at the mirror line, I pick the distance that takes me to Q, this one, and I transfer it to the other side, this one. So that means Q prime is going to be there. That is where Q prime will be. I do the same for P. Now I'm realizing that for P, P and Q are on the same line. Therefore, I just need to measure this distance now from the mirror line to P, and I transfer it to the other side. And I'm realizing that P prime will be at this point. Then now I can join the triangle and come up now with the triangle. Yeah, this is the triangle. This is the triangle. So we are having our PQR prime, the image of PQR and a rotation, a reflection, line y equals to negative x. So that transformation has been carried out. The next is describe a single transformation which maps triangle PQR onto triangle PQR double prime. Therefore, we are having the single prime now, which has been plotted, PQR. Now we need to know what maps it to PQR double prime. So again, I'll begin by joining, if it's R, with R prime. So I will start with R single prime with R double prime, R single prime with R double prime, like that. Then after joining them, I will need to bisect the line joining them. So I stand here and I draw a bisector to the line which joins them. So I've drawn a line, a bisector to the line joining them, a bisector to the line joining them. Sorry, it should be on the two sides. Therefore, beginning from here, I'll need to draw an arc. Yeah, an arc like that. Then standing here, using the same radius, I cut the first arc at the 2 points. Therefore, now I'll need to produce this line now from this point to this point. So that is the line. I've bisected it. This is the first bisector. It should be noted. The next one should be the line joining P and P. Therefore, I will join P double prime and P single prime. Then again, I also bisect the line joining P and P prime. Therefore, standing at P, I can make an arc. Then I extend it to this other side. Then standing at P, I make the same arc. At P, I make the same arc. Therefore, now I can join the two arcs. So now, in this case, this is the second line. In this case, I'm seeing that the bisector is not the same. Not like in the first case, whereby after joining P and P, I bisected, Q and Q, I bisected, and the bisector was confirming to be the same. In this case, I'm getting two different bisectors. But the good thing is that the two bisectors are meeting at a point. The two bisectors are meeting at a point. Therefore, this bisector is coming to the center, origin, and this other bisector for P is also coming to the origin. That means we are carrying out what we call a rotation. Now what I need to compare is, now when I join, because I've known the center now, because the two bisectors are meeting at the origin. If I do the same for Q and I bisect, the line will still come to the origin. Therefore now, I need to know, because this is a rotation now, center origin. This is a rotation. I need to mention that it is a rotation. A rotation. And the center of rotation is 0, 0. Then the other one should be the angle of rotation. So I need to join, for me to know the angle of rotation, I need to join if it's P with the center, P with the center, like that. Then also to the other P, which is P prime. The other P, which is P prime. Then now I measure the angle now. Remember, we are looking for transformation that maps P single prime to P double prime. Therefore, what mapped this P to the other one? I've connected P to the center, then to P prime. Therefore, I need to measure this angle, and I'm realizing that the angle is exactly 90 degrees. Exactly 90 degrees. So if the angle is 90 degrees, now the next question is to which direction? So it is a 90 degrees, and from P prime to the center, then to P double prime, this is a clockwise direction. Therefore, it is negative quarter turn. Negative quarter turn. So this is called a negative quarter turn, or through negative 90 degrees, which is called negative quarter turn. So instead of saying that it is a rotation, center origin, an angle of negative 90, you can simply say that it is a rotation through a negative quarter turn, center O. Center O. When you connect Q to the center, then to Q prime, you measure the angle and you confirm it is the same. So we can move to the next question. Move to the next question. Just on the same, I think we are not through, yeah? We are not through with the graphical. We are not through with the graphical. You can see that we are being told to draw the triangle P triple prime, Q triple prime, and R triple prime such that it can be mapped onto triangle PQR by a positive quarter turn. By a positive quarter turn. Remember, we have PQR. So we want to draw another triangle which requires a positive quarter turn for it to become PQR. That means we should transform PQR through a negative quarter turn. Through a negative quarter turn. So we take this one through a negative quarter turn. That is when we will get a triangle PQR triple prime that will require a positive quarter turn to become PQR. So we take the PQR through a negative quarter turn. That is what we're going to transform immediately. A negative quarter turn now. A negative quarter turn. Therefore, it means a negative quarter turn through the origin. Yeah, about the origin. So we join P to the origin and we extend a little bit so that we may measure negative quarter turn. That means now, yeah, that is 90 degrees in the clockwise direction. That's what you call a negative turn, a negative quarter turn. Then now, apart from the angle of 90, I also measure this distance. So I also take it to the other side. This is where P triple prime will be an equal distance on the other side. I again connect Q to the center origin. So Q to the origin, and I extend a little bit. I extend a little bit so that I may measure. So that I may measure 90. So that I may measure 90 degrees. Then I produce this. I produce this length. Yes. Then now along this line now, I need to take an equal distance so that this is where Q will be. Q triple prime. Then I finally draw for R. So for R, I need to connect R to the center of rotation. Then I extend a little bit, then measure along that line. Along that line, I measure what we are calling the 90 degrees in the clockwise direction, and I produce a line. I produce a line. That means now from R to the center, I need an equal distance so that I may get R triple prime. Therefore, now I can join Q P and R. Q, P, and R. So this is now the triangle which we have drawn, and according to these instructions, the triangle now PQR triple prime will require a positive quarter turn, such that it can be mapped onto PQR using a positive quarter turn. That is why with the PQR we have carried out a negative quarter turn. Now this triangle requires a positive quarter turn to become PQR. That is how we are supposed to go about such a question. The other part, we are told to state a pair of triangles that is oppositely congruent and directly congruent. Okay, direct congruence is whereby you can lift a triangle to the other one without tilting it. For example, we have a triangle like the first one. This triangle and the other one here, the third image here, they are directly congruent. Then opposite congruence is whereby for them to align, for P and the other P prime to align, you need to overturn. Like the first image and the second image, they are oppositely congruent. Unless you carry out a certain rotation, unless you rotate, this figure cannot fall on to this one perfectly. Therefore, oppositely congruent, we can use the first image and the second one, and say P, Q, R, and P, Q, R. They are oppositely congruent. For direct congruence, we've said P, Q, R, and P, the third image, Q, R. So that is how we identify direct and indirect or opposite congruence. Thank you for following. Make sure you subscribe and stay tuned. We're going to soon have another live lesson. Thank you so much. See, people are also turning up. Watu wanaingia tukimaliza.